All right, in this video, we are going to talk through some practice problems involving combination and decomposition reactions. Okay, so our goals here are predicting the products and identifying the type of reaction. So this first reaction, we got aluminum plus oxygen. So it looks like it's two elements combining. So it looks like a combination reaction. And when we combine two elements, notice this is a metal. So aluminum is a metal and oxygen is a non-metal. So when they combine, they're going to form an ionic compound. So we have to consider the charges of these ions. We're trying to predict the products. So aluminum, and I'm going to look on my periodic table. Remember, you've got periodic tables you can look at. Here's one right here. It looks like aluminum has a charge of +3. Oxygen has a charge of -2. So you should be looking at this periodic table to figure out what your ion charges are. I'm going to scroll back down. So aluminum is +3. Oxygen is -2. We do a little crisscross. And I get Al2O3. That is the product of this reaction. All right. The next one, we've got just only one reactant. So when you have only one reactant, that is a hint that it is a decomposition reaction. Because combination reactions look like this, two or more things combining to make one product. Decomposition has one product breaking down into two or more reactants. So I'm going to erase this. So notice how in my first example, I've got one product. In this example, I've got just one reactant. So this tells me it's a decomposition reaction. So when it decomposes, it's going to break apart into its elements, which are hydrogen and oxygen. And I'm going to think about Hofbrinkel. So Hofbrinkel is a way to remember what my diatomic elements are. So if an element's part of Hofbrinkel, it gets a 2 by it. So H is part of Hofbrinkel, so it gets a subscript 2. O is part of Hofbrinkel, so let's get a subscript 2. I can also fill in states of matter here. If I look at my periodic table, I can see that my hydrogen and oxygen are both gases at room temperature. My aluminum oxide, if it's an ionic compound, ionic compounds, you might remember, have very high melting points. We noticed that in our bond types lab. So since it's got a high melting point, it is going to be a solid at room temperature. So under most conditions, that's going to be a solid. All right, this one, it looks like something is reacting with oxygen. That is a combustion reaction. And when something reacts with oxygen, if this thing right here is what we call a hydrocarbon, it's got carbon and hydrogen, then the products are always going to be CO2 and H2O. And we didn't talk about the states of matter of these, but we might know CO2 is a gas just from personal experience. We know it floats around the air. Water can be a liquid or a gas, but it's probably going to be in a gas here because it's got these tend to happen at high temperatures. But you could label it as a liquid too. That works well as well. Okay, so this one I've got just one product. All that can do is break apart. So this looks like a decomposition reaction. Decomposition. And so it's going to decompose into its elements. That's silver and chlorine. And so Ag, is it part of Hofbrinkel? Nope. So no subscript there. But chlorine, is it part of Hofbrinkel? Yep. So I'm going to put a subscript right there. And then this one is another combustion reaction, because I notice it's reacting with oxygen. So it's combustion. And the products that are always going to be CO2 and H2O. And then for this last one, we've got two things combining. That looks like a combination reaction. Combination. Two things are combining. So when they combine, we want to consider the ion charges and do a little crisscross applesauce. So this becomes Mg3N2, because whatever numbers here goes down there, and vice versa. And then I'm going to go back and erase these. Okay. And notice, again, none of these reactions have coefficients in them right now. So we're going to talk about how to determine the coefficients later on. So we're going to talk about that as a separate topic. Like, for example, in this reaction, we will find that in order to make it work, we'll actually have coefficients of like a 4, a 3, and a 2. But we will talk about that later when we talk about the idea of balancing. For right now, we're just focusing on predicting the product. So figuring out what things are made during this reaction and being able to write the formulas of those products correctly. Let me know If you have any follow-up questions, send me an email or ask in class. Thanks.